So you can all see the screen. I think this goes over here. All right. So what I'm going to be talking about, structural evaluations. I'm still going to try and finish by 10:30, but it's going to be tough. Just to give you a quick update on the little background, CAI National has created a task force on exactly this topic. A number of you in the audience have been participating in that task force. Most specifically, the face I can see is Ed San George, who's been an active participant in that task force. We actually have a meeting today at 11, which hopefully we're going to finalize a public policy in regards to CAI National's thoughts in regards to periodic inspections and what I'm talking about. In addition, in New Jersey, Ed heads up the Legislative Action Committee in New Jersey, dealing with a task force dealing with specifically with this topic. And I'm on that task force, and we've also had a couple of meetings. So as we get into it, I'm sure Ed will jump in and may have a few things to say. What I'm going to be talking about today is the basics. What is a building structure? Types of maintenance. Why should your building be evaluated? Deterioration causes and types. What is the process? Periodic inspections. How is it done? And how often should it be done? For those of you who attended my webinar a few weeks ago, you will see that a couple of the slides are being reused, but they're being reused in a different way because, as I mentioned, I'm going to go a little more into the weeds today in this type of thing. So what is the building structure? The building structure is essentially what holds up the building. And on the left, you see a high-rise schematic. On the right, you see a townhouse, but it's essentially the same thing. It's the foundation at the bottom, the columns that go up that support the beams, and that's the structure that holds a building up. So that's what we're going to talk about. What is a building structure and how to inspect it? I thought it might be interesting for you to understand from an engineer's perspective how you actually design a building, because there's a few different loads that you design a building for. There's what is called the dead load, which is actually the weight of the materials of construction and exactly how much does the building weigh. So for example, if it's concrete, it weighs about 150 pounds per cubic foot, and that's the weight, that's the dead load. The live load is produced by the people using the building. So for example, if it's residential, it might be 40 or 50 pounds per square foot. If it's a common area, it might be 100 pounds per square foot. But the live load is based on the occupancy of the building. And these things are given to you in the code based on the occupancy. The wind load is based on your location. It's different. If you're closer to the ocean, typically the winds are heavier wind loads than if you're not close to the ocean. But the wind load generally starts out in a term of miles per hour. So typically in this part of the country, the wind load may be 90 miles per hour, which then equates into a load on the building of 30 pounds per square foot. So that's how wind load is calculated. Snow load, how much does the snow weigh? Obviously in Florida, the snow load is much less than it is in Maine, but snow load. And the last one, which is a typical load, is seismic load. It's a load that's created by an earthquake. And again, it's based on location. So in the diagram, you can see that dead load, live load, and snow load are vertical loads, and wind and seismic loads are horizontal loads that are applied to a building or anything else. But that's what a structural is designed for. What is a structure not designed for? It's not designed for deterioration due to aging and a lack of maintenance. So that's what we're going to talk about. How do you monitor a building for something that it's not designed for? Now, don't get me wrong. People, when they design a building, maybe use materials that last longer than other materials, but it's generally not designed for deterioration due to aging or lack of maintenance. So that's what's left out. So why do you need a structural evaluation? It's to verify the extent of structural deterioration, which is happening. I put in here which is happening because there's no such thing as a structure that doesn't deteriorate. It is happening. This is not inspected as part of a reserve study update. So it's very important to understand that if you live in a community association and you have a reserve study done, it's not looking at the structure of the building. And the structure of the building is not included in the reserve study either. The people who do reserve studies are not required to be engineers. They are required to have some experience in different things, cost estimating and things like that. But do not be fooled into thinking that just because you have a reserve study, that it's checking the structure of the building. Now, you go to a doctor for a checkup every year, I'm assuming. and hopefully nothing is wrong. But you go to the doctor. I would say that everybody here goes to the doctor, I'm guessing, and for an annual checkup. A building is exactly the same. And you need to look at it, give it a checkup. Hopefully nothing is wrong, but you should be checking your buildings. So that's my comparison to me and a building. Some of the causes of deterioration: age, moisture, environmental conditions. Now, I'm going to go back a second. Age. When a building gets older, it's just like us that get older. Now, I have a prop that I brought for today's webinar because 10 years ago, I did not do this, but now I go to a doctor. I go to a doctor 2 or 3 times a year proactively to look at me. And what I'm doing now is I take, if you can see it, she has me taking supplements, D3, CoQ10, all these kind of things. If somebody would have told me 5 years ago, 6 years ago, I'd be taking supplements every day, I'd say you're crazy. It's proactive. It's caused by age. I can't stop it. And it's the same with a building. As buildings get older, just like me, you start to age and deteriorate. I showed a picture before, just by coincidence, it's right here. This is me holding one of my kids 15 years ago. I had dark hair and I have a little baby in my lap. That baby now is 30 years old. So now I have gray hair and wrinkles. So as you age, you deteriorate. Buildings are like people. Moisture is another cause of deterioration, which I'll get into in a little bit of a detail. Environmental conditions. If you're along the coast, for example, and you have salt air and salt water in the air, it will cause your building to deteriorate more rapidly. I don't want anybody to think that if you have a building that's not along the ocean, it will not deteriorate. It will. It may take a little longer, but it will deteriorate. Environmental conditions, temperature. Buildings have a tendency to expand and contract when the temperatures change. And that has an effect on the building and may cause it to deteriorate faster. I'm going to show you an example of that in the next slide. Adjacent construction, pile driving. If somebody's building a building next to you and there's vibrations from pile driving or putting in new foundations, it will have an effect on your building. Now, I want to show you this as an example because the other thing is type of facility. We're involved in a lot of parking garages, and in this part of the country, well, any part of the country, there are a lot of parking garages. They are affected by the environment. In addition, they're affected by moisture, freezing, de-icing salts. When a car is driving in the winter in this part of the country, they drive in, and you don't have to be near the ocean, but they're bringing the salts from the road into the parking garage, which causes deterioration. And I'll talk about that in a few minutes. Also, dynamic loads. What is a dynamic load? It's a load that moves. When we talk about live loads in a building, you may be walking around in a building, doesn't have a huge impact on the structure. But in a parking garage, you have trucks that go in there, cars that go in there, they're turning corners, they're stopping and they're going, and they're creating dynamic loads which make it move. Now, the center picture is something I'm going to expansion and contraction. In a parking garage and in most buildings, the building will expand and contract based on temperature or other things. What happens, the way you alleviate that is you put in what are called expansion joints. This middle picture, and I think you can see my pointer, is an expansion joint in a parking garage. Look what happens. The expansion joint should be going across this opening. The opening allows it to expand, move in and move out depending on the temperatures, but it also keeps the water from going through that structure that is supporting the cars. So when you look at a parking garage and you see an expansion joint and the joint itself is gone, there's no question that the building can still expand and contract. But what goes on underneath it? The water goes through, and in a parking garage in this part of the country, it has salt in the water, and what happens to the structure underneath it? The picture to the right is from a parking garage we're working on. This is what the expansion joint looks like from underneath. The water has come through and it's rusting the steel significantly. So in some places, we actually have to replace the steel because people just see the joint and you don't even think about what's going on under it. So this is a combination of expansion and contraction, salt in the water, and what can happen because of it. Deterioration. And a parking garage is a great example of rapid deterioration because it's subjected to environmental conditions. So again, do not rely on your reserve study. The reserve study is for your common elements for cyclical replacements. And it does not include the building structure. Generally, the reserve study includes things that have a 30-year remaining life or less, and that they are cyclical replacements, meaning that when it has to be replaced, then you start all over again and has to be replaced again. That's really not the structure of your building. So again, do not be fooled into thinking you're okay if you have a reserve study. Now let's talk a little bit about maintenance. There are a couple types of maintenance. Maintenance is keeping something in proper condition by taking care of it to keep it from breaking down. There's two types of maintenance: preventive maintenance, which is for something like on a reserve schedule that has a cyclical life to make sure it gets its full life, and corrective maintenance of fixing something when you find a problem. Like when I go to a doctor and they find something wrong, they do corrective maintenance. What I do is I take my vitamins, that's my preventive maintenance. So you have to keep in mind the difference between the two. So corrective maintenance is the type of things that periodic inspections help with. I thought it was very interesting. People sometimes don't think about the life cycle costs of buildings. If you look at maintenance for a building, maintenance budget is generally in the range of 2 to 6% of the annual operating budget. So you're paying 2 to 6%. Now this is just rough numbers. I think this may be based on office buildings. It's probably higher for parking garages, but say to 2 to 6%. But if you defer the costs by not fixing it and not maintaining it, when you get to the point that you have to fix it, it's going to cost you significantly more than what you would have invested in maintenance. In this case, it says 30 times more than what you would pay to maintenance is the cost of fixing it later if you don't maintain it. So it's very important to keep in mind life cycle costs when you're talking about buildings. So what are periodic inspections? A periodic inspection is like going to the doctor once a year. It's an inspection aimed at identifying issues when they become evident. Like with me, something's wrong, I go to the doctor, it's now evident, you didn't see it before, I have to get it fixed. Deterioration of a building can occur over time due to deterioration, wear and tear. I guess shouldn't use the word twice, wear and tear, and poor maintenance, which I just spoke about. It is progressive, which typically worsens over time. And again, I mentioned reserve studies. Now, I really like this graph that I put in here on the right. This has to do with pavement. Now, on the bottom, it's time. On the left, it's resistance to failure. And you'll see that as the pavement gets older, it starts out new, aging. Then it gets to a point where failure can be detected. So keep in mind, connect this to a periodic inspection. You're going out and looking at your pavement or your structure, and this is the point where the failure can start to be seen. Once you get past this point, if you don't do corrective maintenance to fix it, you get to a point where it's beyond economic repair. So this is the value of periodic inspections, that you get to this point where this little yellow, whatever it is here, and it says potential failure. That's when you start doing your corrective maintenance. And that's what your periodic inspections will tell you, is when you get to this point, because until you get to that point, everything is going to look great. So what are periodic inspections? Now I'm going to start getting into a little exactly what it is and how you do it. There's a great standard out there that's used around the industry. It's put out by the American Society of Civil Engineers, and it's the guideline for structural condition assessments of existing buildings. Now I'm going to show you later on a couple of other standards that are out there based on specific materials, but this guideline is what most engineers use to do their condition assessments of existing buildings. And keep in mind, it says structural. Now I'm going to go through some sections in this, and this is where I'm going to get into the weeds a little. And please, if you have any questions, please feel free to jump in. And let me open up the chat so at least I can see it. All right. So if anybody has any questions you want to throw it into the chat, feel free to do that also. But section 1.1, and I hate to do PowerPoints where I'm actually reading things, but I am going to read things. Section scope and intent of the standard: to provide guidelines and methodology for assessing the structural condition of existing buildings constructed of a combination of materials, including concrete, metals, masonry, and wood. Now, there's a process that you go through to do this, but there are very specific sections within this guide for different types of material. The purpose of the assessment can be undertaken for a number of purposes. This can include developing a performance report. Now, I compare a performance report to, again, going to the doctor and seeing how you're performing. So the best thing that can happen when you do a condition assessment is that everything looks great and you don't have to go back for another year. But in many instances, people and buildings, there are things that you see. What are the qualifications of the person who should be doing this? It's interpretation and results and conclusions shall be performed by a registered professional engineer qualified in the appropriate discipline. Now, there's been a lot of questions about who has the appropriate qualifications to do this type of inspection. Now, there's no question that, for example, in my office, an engineering office, staff members who may not be licensed will go out and identify the conditions under the direction of a licensed engineer. But in terms of interpreting what they come back with, it says somebody can hear on the phone, but not on the computer. Okay, sorry. As far as interpreting the results, every standard I've seen has said that it should be by a licensed professional engineer. And as I go through this, I'm going to show you a couple of reasons why. But this is a great guideline for doing this, which most people use. Now, let's see. All right. Now, section 2. What is the process? The basic process includes a preliminary assessment followed by a detailed assessment. And I'll keep on referring this back to a doctor and us. Let's say you go to a doctor and they say there's something wrong, but it's not their specialty. You go for a preliminary assessment and they may say, go see this ear, nose, and throat doctor or somebody else. But it's a preliminary assessment followed by a detailed assessment. Now, in many instances, the person who does the preliminary assessment may also do the detailed assessment, but like anything else, in some cases, the person who does the preliminary assessment may recommend you go to somebody else for the detailed assessment, depending on what you find. If it is already, in some cases, you don't need the preliminary assessment. I've gone into a number of buildings where they don't need me to do a preliminary assessment because they better get right into doing a detailed assessment because there are problems that you can see instantly without doing the preliminary assessment. Now, what is the process? I'll give you a non-boring guide for regular people, maybe. So if you're bored, sorry. All right, let's go on next. What's next? What is the process? And this process chart comes directly out of that guide I talked about. I'm going to go through each one of these individually for a couple of seconds. But number one, you plan for assessment. Then you do a preliminary assessment. Then based on the preliminary assessment, you do a preliminary evaluation, which includes an examination phase and a judgmental phase. The engineering judgment, does something need to be done next? A cost impact, how much is it going to cost to fix if you need to? Then you go into the next. This is where you have to make a decision. Once you have sufficient information, if the answer is yes, you make a recommendation. If the answer is no, you don't have a sufficient information to come up with a conclusion, then you go into a detailed assessment, which includes much more additional information gathering. And the preliminary assessment is based on generally visually looking at something without taking it apart. But an engineer who looks at a building knows, do I need to take this apart to come to a conclusion? So if the conclusion is we need to do a more detailed evaluation, that then may include some testing. And then the detailed assessment, document review, inspection, and see here it says materials analysis. That's not in the preliminary. Or materials assessment is in the preliminary, but that's by visually looking at it. In the detailed, it's a materials analysis where you're not just assessing it, but now you're analyzing it. Cost impact, sufficient information, and you make your recommendations. So this is the process for doing a periodic inspection. But let's look more. What does this mean? Document review. The first thing is a document review. Now, people say, why do you need the design drawings? One of the things that's very important to have is the design drawings, because in the design drawings, it can identify what the structural system is and identify the primary load resisting systems. Now that's an engineering term. And what it means is, what is the system that keeps the building from falling down? So you're looking at the structural system and the load resisting systems. You're also looking at soils information, previous problems, previous upgrades, and prior reports. Very important that when you do a preliminary assessment, you talk to the person who's familiar with that building, who can walk you around, show you perceived problems. I say perceived problems because they may not be problems, but they walk you around and show you things of concern. They may get you into areas of the building that you can't get into without somebody with a key, but they show you around the building. If there is any work done to the building, you should be told what the work that was done and why it was done. And in many instances, the engineer could see the work was done, and prior reports. Prior reports are critical. And you see here, I put the term baseline. What I mean by baseline is that, and I'm now using the skin doctor example. You go to a skin doctor, I go to one once a year because I'm out in the sun a lot. If they see something on your body and it looks fine, they may take a picture of it. And then a year later, they look at it again and look at that picture again to see if it's gotten worse or something's happened. The baseline report for a building is the same thing. If you see minor conditions, I'll talk about that in a second, you take a picture of it, you document it, that becomes the baseline report for comparison in the future when the next report is done. And I'm going to talk about scheduling and time periods and things like that. But just because you have one preliminary assessment and it says that you don't need a detailed assessment does not mean you shouldn't do a preliminary assessment again in the future, because things change, as I've talked about. But the first step is documents review. Now I'm going to show you an example of why it's important to have the drawings. This is from a building we're working on right now. And this is, we took it apart, but this is what it looks like. Now the question is, if you don't have the design drawings, is this building constructed of reinforced concrete or is it structural steel? Because what you're seeing is a column that with concrete around it. So now when you look at a column with concrete around it, what's the assumption you're going to make? It's a concrete column. But the fact is that this is a steel column encased in concrete. Now we know this because we have the structural drawings of the building, so we understand the structural supports and the structural design of that building. This is one of the reasons why it's very important to have the design drawings, because again, it explains to you what the structure is without taking things apart. Don't get me wrong, there are a lot of buildings. I know there's one parking garage we're working on soon that the building goes way back, and I doubt if we have structural drawings, we have to do different things to confirm what kind of structure it is. But it's very important as a baseline to have the structural drawings if they're available, and that's a reason why. All right, the site visit. The site visit is to assess the structural condition, to look at the conditions, which I'll talk about some of them.
I thought I had it off. How do you turn it off?
Hello? I think somebody, all right. Evidence of structural modifications. For example, somebody may have made changes to the building. We'll be able to see that when we go out to look at it. Weakness in structural members or connections. I'm going to show you an example of that in a picture, but maybe you'll see some deflection taking place in a beam and you'll see some problems, so that you'll see weakness in structural members or connections. Now you'll see that the guides and I separate structural members from connections. Now there's a reason for that, and I'll show you a picture, but keep in mind, a member is maybe a beam, a connection is what connects it to the column, and a lot of times the connection is the weak link. Settlement of foundation. If you go and see a foundation settling, then that's an assessment, you see a problem. And again, meet with the staff familiar with the building to walk through and point out any concerns. Very important. Next, the preliminary analysis. And I'll jump to the bottom. The preliminary analysis is generally the result is a letter report. There's certain things that have to go into it, but according to the standards, it can be a letter report. It's an estimate if the building has adequate capacity. If there's a problem, it gives a damage assessment, identifies structural deficiencies. And for me, it's very, very important, especially if you're doing this as a baseline or any time in the history of the building, you identify the locations with pictures so that you can go back next year or in the future sometime to look to see if it's gotten worse. I will tell you, it will never get better, and it probably will get worse. So don't think your buildings are going to heal themselves. It doesn't happen. All right, now let's jump into the detailed assessment. You see something wrong, and it may not be the entire building. It may be a portion of the building that the preliminary assessment says you should look at it in greater detail. The next step is now to go into the detailed assessment of that particular part of the building where there's concern, or maybe the entire building. But generally, the detailed assessment has to do with a part of the building, not the entire building. The purpose is to determine if the building requires rehabilitation, to identify deficiencies and recommend how it should be fixed. And while preliminary assessment is focused on critical members and connections, the detailed assessment will encompass the total structural system. Because although you may see the deterioration in one area, the question is, how does that affect the overall structure? Because there may be a beam. I'll give you the example of a column. You have a column that goes up 20 stories in a building. If the column is damaged at the bottom, which isn't uncommon because that's where your parking garage is, that is exposed to the elements, how does the damage to that column affect the entire building? I promise you, and I don't have to tell you, that if the column is damaged on the top floor, there's much less chance of a huge problem than if it's damaged at the bottom. And I don't have to tell you what's going on in the world because we all know, but the bottom and where it is in terms of the structural system makes a big difference. And this is one of the reasons why a structural engineer is required to do this, because that one is logical, what I just said. But a structural engineer knows from where the damage is, how it can affect the entire structural system of the building. Because in some cases, you may have a beam that's horizontal, but it's carrying the wind load or the seismic load over to the columns. So you need to understand the structural system itself, not just where the damage is. I mentioned this before. A testing program may be established to find material properties. Let's say you need to check the strength of the concrete. And I talked about this in my prior presentation about concrete and the strengths. And I think I touch on it again in a minute. But you may need to have a testing program. Many, many different types of tests, which I'll touch on. But in the detailed evaluation, you start getting involved in testing. Now, there's a few main types of materials that are used in our buildings. And concrete, and for those of you who are on my last webinar, I went into this in detail, but I want to show it to you in a little different way now. Concrete, it's good in compression and it's poor in tension. Now, if you look to the left here, you see a beam. Can everybody see my pointer? I think you can see my pointer here. So you have a beam. If you have weight on the top of it, you see the weight. The top of the beam goes into compression. The bottom of the beam goes into tension. So what happens? The concrete is not good in tension. So when an engineer goes out and looks at that, if you start seeing cracking, different types of cracking in the bottom of the beam, it may mean that the reinforcing steel isn't enough, or let's say it's rusted to the point where it's not providing the tension strength that you need. So by having engineers look at these things, we can look at it and see, based on the conditions, what can be causing them from a structural perspective rather than just a visual perspective. And that's why, again, it reinforces, so to speak, why all the codes say the interpretation needs to be done by a structural engineer. But I wanted to point this out for concrete, that if concrete is not reinforced with steel to provide tension, then there could be a problem with cracking. On the top, let's say it goes into compression on the top of the beam, and you start seeing crushing of the concrete. Maybe the concrete has started to lose its strength, so it can't support that compression load. But now you're seeing a different condition. You're seeing crushing of the concrete rather than cracking of the concrete, which is, again, a reason why an engineer that's familiar with this should be doing the inspecting and the evaluation. Again, I showed these pictures last time here of beams with the reinforcing steel that had rusted and cracked out the concrete. Here's a column, and you see the reinforcing steel. By the way, there are ways. I had talked about the cover. Cover is very important. It's the distance from the reinforcing steel to the surface. The code requires certain cover distances based on whether or not the member is subjected to the environment or not. There are ways with X-rays and different types of technology to tell where the steel is within the column and the beams, so you can see if it's far enough away from the surface. And there are different ways to do these type of things, which may not be invasive testing, but still gives you information by testing. The right is a picture I've shown of a balcony, very common in high-rise buildings, where when the reinforcing steel rusts, it pops out a piece of the concrete and it can fall 30 floors and hit somebody in the head. Now, when you continue in this guide, this is concrete now. It goes into a lot of detail based on the type of conditions and what they indicate. So for example, section 3.2.1, the condition of a concrete structure may be determined by visual examination in conjunction with computational methods and testing. I talked about the visual, I talked about the testing. What does computational mean? If I have a concrete beam that should have 3 pieces of reinforcing in it, and let's say one is rusting, I can do a structural calculation to determine if that beam is still strong enough, missing 1 piece of steel. I doubt it, but that's what this computational method means. Cracking. Cracking is defined as the separation of concrete into parts characterized by length, direction, width, and depth, and whether a crack is active or passive. Now, I talked about this before. What does it mean to be active? An active crack, let's say in a parking garage, is caused by cars driving back and forth over it, which you get a crack, and it keeps on getting longer and longer because it's an active crack. And it gets progressively worse, so it's active. Versus a passive crack, a crack that may have happened, let's say, because of construction, which is not a problem, but it's passive, it's not getting bigger and bigger. Another key to documenting in your baseline study what the cracks look like, so you can go back a year later to see if they've gotten worse. There are also things that we have used. For example, they're called crack monitors. And I could show you a picture, I should have put it in, but a crack monitor is something that you glue to the concrete, it extends across the crack, and it measures it. So you can go back 6 months later and see if the crack has gotten wider. So there are many different things that you can do, but the engineer determines based on their look, based on the length, direction, width, and depth of all the crack, is it active or passive? Is it getting worse or is it okay? Which from a visual inspection by somebody who's not technically knowledgeable in structures will not give you the answers you're looking for. Another type of crack, this is called delamination. It's cracking or separation in plane parallel to and near the surface. Now, this type of delamination may not be caused by structure. It may be caused by when they put the concrete down, they didn't let it set at the exterior, and now it's starting to delaminate. Keep in mind, the less concrete you have, the less strength, but this may be something not to worry about just based on what the look is. Now you have efflorescence, a big thing with concrete. People look at efflorescence and you see this white surface on the concrete. It means that water is traveling through the concrete and carrying salts to the exterior, which deposit on the outside. Now, from a structural perspective, the efflorescence really does not affect the structure of the concrete, but what is it telling you? It's telling you that water is traveling through the concrete or the brick or whatever it is, and if there's steel inside that gives it its strength, what is the water going to do? It's going to rust the steel. So efflorescence is a sign of potential problems. It's another thing to look at. This one, pop-outs. This is when just a little section of the concrete pops out, breaking away of small portions due to internal pressure. So the question is, just from a couple pop-outs, it's probably not going to affect the structure, but what's causing that internal pressure to make it happen? Here's another one, spalling. This is the one that people are most familiar with. Detachment of fragments in the shape of flakes from a concrete mass. This is very common, that the reinforcing steel gets wet, it rusts, it expands, and the concrete spalls. This is very common, but spalling is another thing that you look at to determine what's causing it and how does it affect the structure. Now let's talk about steel. Steel has the same strength in every direction. It's not a combination of concrete and steel. It's just steel in all directions. What is the most common thing you see with steel? It rusts. Now, when an engineer looks at this, you see this picture on the left, you're seeing two, and the right, you're seeing two things. You're seeing the steel beam and to the left, you're seeing the connection where the bolts are. Now, let's say you looked at this and the steel beam was not rusted, but the bolts were. You have a structural problem because the bolts are holding up the beam. But now in this picture, it looks like the steel bolts are okay, but the beam is rusted away. So there's a different type of structural problem going on here, and it may be a different type of fix to correct it. But by somebody looking at this, obviously, anybody who looks at this is going to say you have a problem. The question is, what is the impact of that problem on the structure and the structural system, which an engineer can, who's a structural engineer, can look at that and tell you. And I will tell you, this beam has a big problem. We're in the process of replacing it and the connection. So this is a big problem. Now to the right, you look at it, you see the column and the beams coming together. You see the connections and you see the rusting. Very common. Sometimes things are hidden. For example, this steel has a fireproofing coating on it. So how do you know it's rusting? If you look at the fireproofing coating, you start seeing rust stains. But this is the type of thing you see with steel, and it's identified in this guide of the different conditions and what the impact it could have. Now, I talked about connections. Connections play a major role because this is connected. You have a beam coming in from both sides. Now, look at this one beam. This beam is only, let's say, 12 inches deep. This beam may be 24 inches deep. This beam has 1, 2, 3, 4, 5 bolts. This one has 10 bolts. So clearly, this beam, the bigger beam, is carrying a heavier weight, and it has a bigger beam and more connections. But if you looked at this, would you see a problem? In the connection, the beam looks great, the bolts look great, but what's the problem? An engineer looks at this, and what happens? What do I see? I see that you see this plate that you're bolting the beam to the column with. Why is there a space here? Why is there a gap there? Now, I look at that as an engineer who understands the design, and now I know, I look at that and say, there may be a problem with the bolts because they are being subjected to different types of loads than if this plate was just directly against the beam. Now, I know I'm using technical terms, and I'd be happy to explain it, but I look at this and I say there could be a potential problem where somebody else who looks at this who is not a structural engineer may say it looks great. So connections are very important. Here's some more example of connections with corrosion on the left. I think that right picture is the same picture again. Now, section 3.4 is masonry. Same type of thing with masonry. Brick. Brick can be a structural part of your building. It may not be the main structure, but it could be holding up certain things. But masonry is a structural portion of a lot of buildings, and it talks about looking at the masonry and how to look at it. Next, the brick facade. Here, the combination of steel lintel that rusted away. Now the brick is settling. And here to the right, the brick isn't attached because the steel ties that hold it to the building may have rusted and it fell off. But there's many different things to look at, and you look at it again from a structural perspective. Wood. Wood has many different qualities. Wood gets weaker if it's wet or subjected to hot temperature. Most of the buildings we all live in may be subjected to moisture, but the temperature doesn't really get hot enough to affect its strength. But wood will deteriorate. This is what happens. You can't even see it. On the left, this is a wood deck. The water's getting through underneath the decking. You really couldn't see this. This one, I think, is pretty close to the ground, so nobody's climbing underneath to look at it. But when you start pulling the decking off, you see the deterioration. We have been involved in a number of communities where we've shut down the wood decks for safety reasons, and they're replacing the decks because of these type of things. Now, the right is interesting. This is something we just saw in the last week or so. This is a very heavy-duty wood truss, it's called, holding up a roof. Now, you see what's happening here? It sits on the end on this wall, but then as soon as it gets away from the wall, you start seeing a deflection. It drops down. Now, the wood looks like it's in decent shape, so why is this happening? Now, a layman who's not a structural engineer would look at this and not really understand what's going on structurally, but I look at this and say, you've got this top, what's called cord coming down. Now, this cord should end above the wall where it's being supported, not 3 feet away from it, because it's taking the entire weight of the roof and putting it on this bottom cord out here rather than here, which is causing it to deflect. So when you look at these things, again, this is a reason why that when you do these evaluations, you're looking at them from an engineering perspective of how should it be designed and what's causing this deflection to happen. I will tell you, this makes me a little nervous. This thing's probably been sitting here for 50, 60 years, but it's progressive. This deflection will continue, and there really needs to be some kind of column or something under here to take the weight of this top cord so this deflection doesn't continue. But these are the types of things you see, and you can see the engineering knowledge that's necessary. I just pulled out this page because in this guide, there's about 20 different pages for different types of materials about different testing methods that you can use to identify different problems. And here it goes into radiographics, x-rays, all types of things. It's kind of interesting because one of the test methods here, it says visual examinations is a test method. And it says it's generally low cost, rapid evaluation of concrete or any, but it says who should do it? Trained evaluation required, primary evaluation confined to surface of structure. So again, that goes back to the preliminary analysis, but visual examinations can tell you a lot, especially when you know what you're looking for. All right, now what about frequency? How often should you do this? 5 years, 10 years, 40 years? It's based on building type, building age. It's based on all these things, but just to give you some guide, there are many recommendations regarding the frequency. The age of the building. The older the building, if there's never been a preliminary evaluation done, I think it should be done right away. Buildings get old and these things happen. It is happening. The use of the building. We talked about a parking garage. Wouldn't you agree that a parking garage should be inspected sooner and more frequently than the column in a beam in a building that's not subjected to cars driving back and forth and salt and all this kind of stuff? The condition of the building. If you go into a building and it's older and you see some things that need to be fixed and you fix them, I would say that you should then evaluate that building on a more regular basis than a building that is brand new. Geographic location, a building along the coast. Again, building along the coast, salt water can cause problems to occur more quickly than if you don't have salt water. So a building along the coast may be more frequently, but keep in mind, a parking garage is subjected to salt water also. So I'll draw the comparison, but geography may have a bearing. If an assessment has not yet been performed, it can be served as the basis for establishing the frequency. So if we were to do a baseline study of a building, then in that study, we would make recommendations in regards to what to fix and when the next inspection should take place. And keep in mind, in all cases, governmental requirements should be adhered to as a minimum. For example, those of you in New Jersey, there is the 5-year residence inspection done by the DCA. It's every 5 years. But let's say there's a problem that needs to be looked at in 2 years. It's the maximum time frame. The other thing is, don't be fooled in thinking that by the New Jersey 5-year inspections that they are looking in detail at the structure of the building. That is not part of what they're doing. They're looking primarily at safety issues regarding to fire safety and those kind of things. So again, don't rely on that to give your answer. All right, so general guide, no more than every 5 years. If a building is more than 5 years old and you've never had an inspection of the structure, my suggestion is you have one done. If the building is less than 5 years old, within a year, in order to establish your baseline, and then you would establish the time frame. And Ed will tell you that originally the national standards was talking about having the inspections every 10 years. And we've talked about it, and we're reevaluating that and probably going to lower it to 5 years rather than 10 years because things can happen much more rapidly than you think they can with these type of things. The thing that's left out of here is what type of building. For example, if you have a high-rise building with a parking garage underneath it, it's much, much more critical to do periodic inspections on a very regular basis. But let's say you have a townhouse community, and we're talking about community associations, and it's a condo, and the structure of the building that is the limited common element is the wood decks. Does that mean you have to inspect your wood decks every 5 years? I would say that depending on the type of building, there are some that should be looked at much, much more frequently than others, and there are other critical things to look at. So like on a townhouse building, we see a lot of problems with wood decks, but not with the structure of the building. So these are just meant to be a general guide, and the type of building has an impact on how often and what to look at. What's the primary inspection you're looking at? These are to look at the structure. There are some secondary things that people look at also, such as affiliated structures and mechanical systems, like a retaining wall. You have a wood retaining wall that's rotting away. It's got a structural problem. If that collapses, I doubt if it's going to affect somebody from a life safety perspective. So you may want to have it inspected, but it's not a life safety issue. You may have a dam, a concrete dam. How often should you inspect that? The structure. But then you have mechanical systems. In a high-rise building, you need to make sure your fire protection sprinkler system works. So that should be inspected based on the type of building on a regular basis, as well as the structure. What to do every day as a manager? Look for rust. Manager or homeowner, whatever you are, wherever you live, wherever you work, if you're walking through your building and you see rust, it's the sign of a problem occurring. Concrete, look for cracking, look for the efflorescence, look for rust. This picture, which I like to use, shows efflorescence to the left and rusting to the right, which means water's coming through. In this spot, it hasn't rusted yet, but in this spot, it has. This is a sign that something going on. Wood, look for wood deterioration. You can see it. My famous comment, I think people have told me, is it doesn't take sometimes an engineer to identify you have a potential problem, but you do need an engineer to tell you how to fix it and how bad the problem is. But if the problem is identified, fix it. Now, this is what you should not do. I love this example. This is a parking garage where there was water coming through. So to keep the water from dripping on the cars, they put in a blue tarp. What does this do? It gets the water away from the cars, but it covers up the fact that the steel beams above it are rusting away. Don't do this. If you have this in any of your communities, my suggestion is pull it down and look at what's going on underneath it. I gave a seminar similar to this a couple of weeks ago, and a manager said that they have this in one of their parking garages. I said, you got to pull it down and look at it. And then, keep in mind, managers have risks also in this kind of thing. Everybody likes to sue everybody, as we all know. So you really need to protect yourself, protect the people who live in your communities by not letting these things happen and understanding the basics of what's going on so you can make sure things are identified and fixed. If you need money for emergency work immediately, I go back to the reserve study in case you need an emergency. Just one quick example. If you look at your funding plan, this community, you can be fully funded or baseline funding without going into a lot of detail. So in this case, if you go from full funding to baseline funding, you can borrow close to $2 million to do an immediate repair. I will tell you that one of the things that CAI is going to probably have in its public policy is something that says that it's recommended that if you need a special assessment for a life safety issue, the Board of Trustees can override the governing documents, and it does not have to go to a vote of the unit owners. I'm sure you've all seen it or heard about it, that you have the unit owners vote against something. What if it's an emergency situation? And I think it's very important that the board have the opportunity to override the governing documents to go for a special assessment without having to go to a vote, because if it's a life safety issue. But in this case, I went off track a little. You can borrow close to $2 million from your reserves for an immediate repair, but make sure you pay it back. Now, I just want to show you, I'm pretty much done. I want to show you some of the references we used. In the United States, there's only 2 or 3 places across the country that have requirements for periodic inspections of the structures of buildings. That is going to change in the next year or so, I promise you. This is a guide from Ontario, Canada, structural condition assessments of existing buildings, and they require it to be done on existing buildings, if I'm not mistaken, every 6 years. This is what's done. In Singapore, they have safe structures and safe buildings where they require buildings to be inspected for structural issues. And if I'm not mistaken, which is kind of weird, it's every 10 years for residential buildings and 5 years if it's not residential, which is kind of weird. To me, it should be related more to building type than building use. But in Singapore, they have specific requirements. In the United States, the only requirements I know of are in Dade County, Florida, Broward County, Florida, where their structural inspection mandate was every 40 years, which, as you know, is going to be changed. And in California, they have requirements that all wood decks need to be inspected every certain amount of time because they've had failures of wood decks. The only place you see very specific requirements in terms of inspecting any type of structure in this country are in the cities. They're called facade inspection requirements, where, for example, New York has local law 11, where every 5 years you need to check the structure of the facade. I always say that there are more regulations to protect the people walking by them than to protect the people that live in them, which is going to change. But there are a lot of cities in this country that have facade inspection requirements. If anybody would like to know, I have the list. I can tell you every city, and in every one of those, it's required to be inspected by a licensed engineer and architect, primarily licensed engineers. And there are timeframes that generally start at 5 years and sometimes go up to 10 years. But CAI also has this guide, Condo Safety. If you look at the CAI national website, this is a book that you can download, New York City Facade Conditions. It's a great book. It's not dealing with the structure, but it's about 60 or 70 pages with pictures of every single type of facade, the type of problem you could have, and what causes it. This is the standard I was talking about, ASCE Standard Guideline for Structural Condition Assessment. This is put out by the American Concrete Institute, strength evaluation of existing concrete buildings. So once you see problems, how do you evaluate the strength? This is guide for conducting a visual inspection of concrete in service, put up in the American Concrete Institute. There are a lot of good references out there. This is a publication put out by CAI called Breaking Point, Aging and Examining Aging Infrastructure and Community Associations. And one of the parts of the aging infrastructure is no question the structure of buildings. And now I will open it up for any questions anybody might have. That's the presentation. I'd be happy to share. We'll send everybody a copy of the presentation. I hope that it helps you understand a little bit more about what the structural evaluations and why you really need a structural person to look at it to understand the extent. And I see Bella, are you raising your hand? No? Okay. Does anybody have any questions, comments? And I'll also say that this webinar was a result of a webinar I gave a few weeks ago where there are a lot of questions about how you do these types of inspections. So if anybody has any thoughts or suggestions or would like to have any other kind of webinar, please email to us and we'll be happy to put it on for you. Or if anybody would like this presented to just your company, for example, management company. Oh, there's Gary Mursky down in Florida. Gary, you have a question?
I do, Mitch. Hi. Great presentation. As you know, I'm in Florida and I live on the ocean. And we just had a board meeting this week to talk about these issues. So we're preparing, we're doing our 5-year examination, which used to be kind of random on balconies only. And now we're preparing to do a more extensive radiographic inspection with the company that has done the balcony inspections in the past. So we're trying to get ahead of whatever's going to happen as far as doing the baseline reports that were by a structural engineer. You think we're wasting our money to do something more extensive before legislation is passed? And we're not in Broward, we're north of Broward in Dade County.
I think that anybody in an older building should do that. Balconies are a big problem in buildings, not only along the ocean, but concrete balconies are an ongoing problem for many different reasons. But the rest of the building should be looked at. And people get afraid because they say, what is the cost of doing this preliminary study? And just to give you an idea, you're probably talking in the range of, let's say $5,000, depending on the building. It varies. And there's also one of the things we talk about on national level from me is because people have a tendency to ignore that, including on the reserve study for the building, let's say $5,000 with a life of 5 years. So you're accumulating $1,000 a year. So every 5 years, you do this type of study. So I would suggest if it's a high-rise concrete and a structural steel, I think you really need to establish a baseline. The best thing that can happen is nothing's wrong. And Gary, maybe you can explain, you had mentioned a radiographic study.
That's
Gary
correct.
had showed this to me, and I think it's kind of like an X-ray of the concrete to show where the reinforcing steel is. Am I right?
Right, right. And we did that because we had soffit failure on our one-story cabana building, which exposed cracks in the connections between the concrete beams and the columns. And there's only 2 columns. And we brought in the radiographic testing company who does bridges, concrete bridges, and recently did checking on some of the local bridges that needed extensive repairs. So yes, being on the salt water is certainly an issue. What we're doing, Mitch, is we're having our maintenance people go into every unit to look at the balcony conditions, looking for cracks, and then we do spalling repairs, and then we're going to bring in the testing company. Do you think that's wise? I mean, should we hide? I mean, we're actually fixing the problems before the radiographic testing is done.
Well, I would say, I mean, I'm not 100% sure how the radiographic, what it'll give you, but the problem with spalling is if you know it's there and something falls, you're on the hook. The board then knows about it and they didn't fix it. But again, I would look at all of them because generally to do spalling repairs, a lot of times you need to have scaffolding. So you're not going to scaffold to just do one balcony. You want to scaffold to do an entire row of balconies at the same time. And so the other thing that we have done, we did with a high rise is we did a drone evaluation of all the balconies to see what we could see visually. And there's no question that it's better to walk every single one of them, but it's relatively inexpensive also to do a drone to look at them just to get an idea of what's going on, especially areas like that aren't on the balcony that you can see. But the best thing clearly is to do a visual inspection of every single balcony. And from a balcony, you can look at the one that's above you, below you, and you get to see all the sides of it. But balconies are a danger zone. And concrete on the ground, concrete is a danger zone also, but it's pretty easy from a preliminary evaluation to see what's going on with cracks and efflorescence and rust stains. Does anybody have any questions for Gary? He's got a building that he's being pretty proactive down in Florida.
20 stories.
20 stories. Gary lives on the top in the penthouse, I'm sure. One question in the chat room is, we're now in budget season for 2022. What is a reasonable amount to budget for a structural evaluation? The condo is a mid-rise 91-unit building with 6 levels apartments, 3 levels underground. The thing that jumps out at me about this one is not even so much the building, but the 3 levels of underground garage. And I'm assuming that the 3 levels of underground garage are below the residential building that are not off, and it's not off to the side. So keep in mind what I talked about in terms of garages that are exposed to the elements and salt and all that kind of stuff. But you're talking about in the range of, I would say, $5,000 or $6,000 to do a preliminary evaluation that you can use as a baseline going forward. And most engineers will give you a price for doing this. Just, it doesn't cost you anything to get a proposal. I would just suggest that when you do ask for proposals for this type of thing, somehow make it apples to apples. And you may want to say, give me a proposal to do this in conformance with that ASCE guide or something like that. So at least you're getting proposals based on some type of standard. Is there anything else anybody has? Okay, well, thank you very much. I apologize to everybody for the technical difficulty I had in the beginning. And have a great week. And if anybody ever has any questions about any of your buildings, you want to just take a picture and email to us, we'd be happy to look at it for you. So thanks, everybody. Bye, Gary.
Bye, Mitch.
Bye, everybody.